Okay, today we're going to talk about function review. There's a couple of things or concepts that you should know the terminology for. First is a relation. A relation is a set of ordered pairs that have some sort of relationship. A relation is not necessarily a function, but all functions are relations. So a function is a relation where every input of an ordered pair has exactly one output. The input of a function is the independent variable, and the output of a function is the dependent variable. The set of all inputs is called the domain. So all your inputs are x values, those are your domain, and the set of all outputs is called the range. Those are your y values. Mapping is a drawing. It shows how each element of the domain is paired with another element in the range of a relationship or a function. For functions, we have special notation. A regular equation could look something like this: y equals, 3x plus 5. If I have a function and I want to use function notation, we would do f of x equals 3x plus 5. An equation doesn't necessarily have to be a function. If you know the equation for a circle, it's x squared plus y squared equals r squared. That's an equation, but it's not a function. Okay, so here's an example. Oh, there's a table E. Here are my x values, and here are my y values. Is it a relation or a function? All right, if you guessed that it's a relation and not a function, you guessed right. If you look here, I have two twos for my x values. These right here make it not a function, because for every input I have to have exactly one output. Kind of tricky because it makes you think that this would not be a function, but that doesn't do it. If you think about a parabola, I can have two y values that are the same, but they have to have different x values. Okay, so it's the fact that I have two 2's as x's. That would look something like, where's my eraser? That would look something like two x values that are the same. That's not a function. Okay, relation or function. Here's an example of mapping. That means that 5 is an input, it maps to 1, that's my output. 7 is an input, it maps to 2, that's an output. And 4 maps to -9, that's an output. And 0 is my input, and it also maps to 2. If you guessed that this is a function, you are correct. You'll notice that I have only one x value, one y value for every x value. All right, ordered pairs, relation or function. Again, I'm going to look at the number of x values to see if I have any duplicate x values, and I don't, so this is also a function. All right, another quick and dirty test to tell if I have a function is to take and look at all my x values. How could I do this? I don't know. If I take a pencil or something straight and I run it across the graph, yours would be invisible. I have to draw lines. You'll see that here I have two x values. I have an x value here and here, an x value here and here. That's why this is not a function. And here, if I look, I only have one x value. If I look down this line, I only have one x value. And down here, I only have one x value. So that is a function. So we can evaluate functions. We do all the time, actually. I have 4 functions here. I have f of x, g of x, h of x, and I of x. So for my first example, I want to find f of negative 3. Well, into my f function, I plug in a negative 3. F of x is x squared. So wherever there's an x, I plug in negative 3. X squared minus 3 times negative 3 gives me 9. Minus negative 9, which is 9 plus 9, which is 18. Here, you try g of negative 1, stop the video, and when you're ready, start it back up. So g of negative 1 is equal to 2 times negative 1 minus 1, which is negative 2 minus 1, which is negative 3. Easy. Another thing we can do with functions is we can operate with functions. So I want to find f of x plus I of x. So f of x is x squared minus 3x. I want to add to that I of x, which is negative x squared plus 4x minus 2. So I'm simply going to combine my like terms. First thing I'm going to do is move that second function out of the parentheses. I don't need them because I'm doing addition. And then I'm going to combine my like terms. X squared minus x squared is nothing, or 0. Negative 3x plus 4x is positive x minus 2. And that's it for adding. I want to find I of x minus g of x. I can also subtract two functions. So I of x is negative. It's going to be almost the same as addition, but I have to be a little careful because I'm subtracting, which means I'm subtracting all of g of x. So I have to protect it with parentheses. And that means that I'm going to distribute this negative sign. And then I can combine my like terms. So I have negative x squared. I have a 4x and a negative 2x. That's going to give me a positive 2x. Negative 2 plus 1 is negative 1, and that's it. That's as far as I can go with that. We can also multiply two functions. Let's multiply f of x times g of x. So f of x is x squared minus 3x. And to that I'm going to multiply g of x, which is 2x minus 1. Here I have to do the dirty deed of foiling, and I get 2x cubed minus x squared minus 6x squared plus 3x. When I combine my like terms, I get 2x cubed. Negative 1 minus 6 would be negative 7x squared plus 3x. And that's it for multiplying. Well, if I can multiply, most of the time I can divide. So I of x would be negative x squared plus 4x minus 2. I want to divide that by x squared minus 3x. And if I want to carry this further, maybe do some long division. I know what you're thinking, don't say it. Depending on what you're doing, this might be sufficient because you can't simplify it any further. But this would be negative 1, which would be negative x squared plus 3x. And then I'd subtract, and a negative x minus a negative x squared is nothing. And 4x minus 3x would be x minus 2, because I have to bring the 2 down. And if I needed to divide for some unknown, ungodly reason, this would be my leftover. And this would be the answer. But most of the time, this will suffice if it's not simplifiable. All right, I can also multiply by a scalar. So I have 3 times g of x which would be 3 times 2x minus 1, which is just going to be 6x minus 3. That's pretty easy. And I can do any combination of any of those operations on functions. So here, you try this one, g of x minus I of x. Pause the video, start it back up when you're ready to check your answer. All right, let's do this. G of x, 2x minus 1, minus I of x, which is negative x squared plus 4x minus 2. Let's distribute this negative sign. That's going to be plus x squared minus 4x plus 2. Combining my like terms in standard order, that's the highest power, so x squared, 2 minus 4 would be minus 2x. Minus 1 plus 2 is going to be plus 1. And that's it. One more for you to try. Pause the video when you're ready to check your answer. Start it back up. All right, this one's a little bit more complicated. I have 2 times g of x plus 3 times f of x. That's going to be 2 times g of x, 2x minus 1, plus 3 times f of x, which is x squared minus 3x. Distribute first. Still have to follow the order of operations, and that gives me 4x minus 2 plus, distribute this, 3x squared minus 9x. And combining my like terms, I end up with 3x squared. 4 minus 9 would be negative 5x minus 2. I think I have one more for you to try. Yes, one more. This is negative g of x divided by h of x. It's a little evil, but pause this and restart when you're ready to check your answer. Okay, negative g of x. I'm just kidding, it's not as bad as it sounds. Negative, oops, gotta erase that. Made a mistake. Really, that's such a wimpy eraser. Good for people who don't make mistakes. All right, negative g of x. It's important to protect g of x with parentheses so that you don't forget to distribute that negative sign to both of those terms. Divided by h of x. Ah, that's gross. All right, it's not that gross. Distribute the negative sign. Negative 2x plus 1 divided by 4 to the x, and you're done. All right, another thing we can do with functions is we can combine them or compose them. Out of 2 functions, we can make a completely new function. So the notation for composition of functions, this here does not say fog. It's f of g of x. It's the same as this, f of g of x. So if I wanted to find f of g of 2, well, I have to go back to my functions that I had on the other page. I need to write them down. F of x equals x squared minus 3x. And g of x was 2x minus 1. Okay. I want to find f of g of 2. So you might see it as this. I like this notation better because I think it's more intuitive. So g of 2, I'm going to go ahead and replace g of 2 with g of 2 here. 2 times 2 minus 1. That means I'm looking for f of 4 minus 1, which is 3. And then I can just put a 3 into f. And that gives me 0. Pretty easy. now I want to find h of f of x. Well, I need to figure out what h is first. H was 4 to the x. All right, so I want, instead of evaluating a certain value for x, I want to find a new function. So h of f of x would look like this. H of f of x is x squared minus 3x. So everywhere up here, everywhere I had a 3, I plugged it in for x. Well, everywhere I have an x, I'm going to plug in x squared minus 3x. So I have 4 to the x. This is my new x value, so it's 4 to the x squared minus 3x. And of course, I'm going to have you try some of these. Let's write down those functions again. F of x is x squared minus 3x. G of x is 2x minus 1. I of x is x squared plus 4x minus 2. And h of x is 4 to the x. All right, so you try these, find g of f of 2 and I of h of x. Pause the video and restart it when you're ready to check your answers. Okay, so g of f of 2 would be 2 squared minus 3 times 2. That gives me 4 minus 6, which would be negative 2. G of negative 2 is going to be 2 times negative 2 minus 1, which is negative 4 minus 1, so that's negative 5. Now if I want to find I of h of x, first I like to rewrite it. H of x was 4 to the x. So everywhere there's an x in the function I, I'm going to replace it with 4 to the x. So 4 to the x squared plus 4 times 4 to the x minus 2. And if I simplify this, I have a power raised to a power here. That'll be 4 to the 2x plus 4 times 4 to the x. I can't combine these 4's because order of operations says I have to do the exponent first. So it just stays as, oops, not 4 to the 4th, unless x is equal to 4. It's going to be 4 to the x minus 2. And that's it. You're done. Thanks for sticking with me through all of this. And next time we'll talk about inverse functions.